You're an iOS developer. You switch to Swift 6. You start building your project and more errors show up. Every time you fix something, a new error shows up. You go into your code. You main actor all the things because that's what we do. That's how we solve things. Might actually be a solution, but more about that later in this video. But eventually, I'm pretty sure that many of you switch back to Swift 5. And that is such a disappointment, but I'm sure that there is an answer. And the answer is Swift 6.2. And in this video, I'll tell you all about it, and we will talk about approachable concurrency. But before I do, I want to take you on a little tour. Because Swift 6.2 is a destination. It's not a final destination, but it's been a journey from a starting point happening in 2017. I still remember myself reading that manifesto, and I was like, yes, we will get async await. No more closures. But it took a while. Before we really got our hands on async await, it was 2021. This was the very first release. It worked, but it wasn't as perfect yet. Eventually, Swift 6 was officially there. Compile time thread safety. It's quite a promise. And in a way it worked, but you will actually learn whether it works when you get your hands dirty. Real app projects trying this out. Now, this year, 2025, in February, we got a vision document about improving the approachability of data race safety. This is kind of the first time we heard the word approachable. And there is a good reason they did this, because the things they thought would work eventually didn't work out the way they thought it would work for real case scenarios, for your app projects. This vision document is a must read. And eventually we got Swift 6.2. The official release happened in September after the announcement took place at WWDC. And Swift 6.2 is full of proposals. Let's look at the list. It is quite a big list. Now these are all the changes that went into Swift. And not all these changes are interesting for you as an iOS developer or for you as a macOS developer. But there are a few that relate to concurrency. And those changes for the future are a battle of today. And I'm telling you this because many of those are upcoming features. They aren't per se enabled by default. And due to that, it's impossible to say on which thread this code will run. Because it depends which upcoming features that you enable. Or maybe you change the default actor isolation, which will also influence this piece of code. So my goal today is to help you understand Swift concurrency with Swift 6.2 and up. And I want to do that by looking back into this list of proposals. Now it's a big list, but these are the only ones related to Swift concurrency. And we can narrow down the list even more, but just looking at these four. If we combine them with a few other proposals from Swift 6 and Swift 5.9, we get approachable concurrency. And this should very much be the answer for us all to finally adopt Swift concurrency in all our projects. Now, you can already look up approachable concurrency in your build settings. It looks like this. And on the right-hand side, you have a little summary. It says, enables upcoming features that aim to provide a more approachable path to Swift concurrency. Exactly what we want. We don't want all those compile time errors, right? We want to kind of like adopt Swift concurrency because compile time thread safety is amazing. But the path towards it was quite hard. You can also see the summary showing up a few upcoming features. These all relate to approachable concurrency. Now, this is the vision document that I spoke about earlier, and it says a few interesting things. It can be frustrating to adopt, and they want to improve the usability of Swift 6. What I especially like, and shout out to the Swift team, they're honest here, right? Like, they had a certain vision, but like always, you never know if that vision actually works out. And they reflect, they're honest, and they look forward. They want to improve our language. So it's such a great time to be a Swift developer. And you can say approachable concurrency, the build setting we just saw, is the answer on this vision document. So the vision document was released in February, and we already have a few proposals in September being released, helping us adopt Swift concurrency. And in the document, they talk about a few phases. Phase 1 being writing sequential single-threaded code. Phase 2 would be writing asynchronous code without data race safety errors. And phase 3, introducing parallelism to improve performance. This might be a bit hard to understand, so I like to use a bit simpler words. Phase 1, no concurrency at all. Phase 2, suspend execution without parallelism, right? So you wait for one asynchronous method to return. There aren't multiple asynchronous methods running at the same time. That would be phase 3, which we would like to call advanced concurrency. And yes, this is actually new. Before approachable concurrency, it's so easy to run in a maze of Swift concurrency failures, errors, and warnings. And that's something they want to solve. It should be easy to adopt Swift. For newcomers, it should be much easier to start writing code with Swift. And hopefully, approachable concurrency is the answer on that. But how do you do that? How do you make concurrency more approachable in your existing projects? And for that, I want to start with the basics. Because what are upcoming features? If you follow my weekly newsletter, you'll get an update every week about the proposal changes. A proposal starts with a review. Eventually it might get accepted or rejected, but eventually you will know whether an upcoming feature actually becomes part of the language. Super interesting to follow along. When you click on such link, you'll end up at a GitHub repository. It's an open source repository and you can follow along all the proposals on the forums. They will discuss each proposal and you'll even be able to influence the direction of a certain language change. Each proposal comes with a certain metadata list. First one is the status. This tells you the current status of the proposal and if it's implemented, in which version it became available. There's also a related vision document. You can use this to read a bit of the background story. For this one, non-isolated async functions, you can read the vision document about approachable concurrency. Not all proposals, but many have an upcoming feature flag. This means the feature isn't enabled by default, but you can opt in via the build settings. And these proposals are great. I highly recommend reading this, basically the whole document, but if only the motivation, because it shares a background story. Why do they change the language? It can be frustrating, right? A language change, but if you know the motivation, you might feel better about it, and you might better understand how the feature works. And once again, the team is super honest here, right? They made a decision in the past, and it had a number of unfortunate consequences. I bet you want to know these consequences and why they changed the language this way. Now in this video, I show you how we can use such proposal. So we copy the upcoming feature flag, we paste it in the build settings, and then you can look into the quick help and see where it's related to, right? So in this case, it's part of the approachable concurrency build setting. You can also search for non-isolated and you'll find the upcoming feature flag accordingly, which allows you to opt in specifically for this feature. There's also an extra declaration that you might find useful. Inside packages, you can also enable upcoming features. You need to make sure that you use the correct upcoming feature flag. The Swift tools version might also be required to update to the required version. Then I want to talk about the importance of migration tooling and mostly why you should use this, and if you don't use it, what will happen. Take this example. We have a non-isolated class called not sendable, and we print out the current thread. Note that printing out the current thread can't be done by the Note that it's not easy to print out the current thread. I'm using an extension method here, which I'm happy to share if you just contact me. It's just a minor detail, but either way, it allows us to print out the current thread and go over its sequence. So I have a new threading demonstrator here attributed with the main actor. And at first it prints out the main thread. Then we go into our not sendable instance, which prints out a background thread. Now this is when we didn't enable the non-isolated, non-sending upcoming feature, right? This is the current behavior, so to say. Eventually we return back on the main thread. Now imagine you're enabling this upcoming feature without a migration tool. We didn't change the code at all, and we run our program again. We start on the main thread, we perform the async method, which now suddenly runs on the main thread. And you can imagine the impact of this, right? Apple could even reject your app because it's suddenly blocking the main thread, making your app unusable. This is one of the many mistakes, and I actually have a dedicated video showing you the 5 mistakes many developers make with Swift concurrency. If we go back, we resume on the main thread just like before. And this is what is happening behind the scenes. Non-isolated non-sending is getting added, and it means that it doesn't send the object or the state to another isolation domain. That's why we keep running on the main actor isolation domain of the callee. That clarifies why we're not running on the background thread. So to better understand its impact on approachable concurrency, if things run in the caller's context, you don't have to hop to a different isolation domain, which is no implicit domain switch, and you don't need sendable. In other words, much fewer compiler errors or warnings. Now instead, you could choose to go for the migrate option. And when you start building your project again, a new warning will show up. And if we zoom into this warning, you can see that we got an apply and fix directly method, basically allowing you to fix this right away via Xcode. But you can also use the question mark to learn more about this feature. And that will bring you to a new documentation page. And this also shows on the left-hand side which upcoming language features are actually supported by this migration tooling. Not everything can be migrated at this point, but the features that are able to be migrated, you should definitely use the migration tooling. And this documentation gives you a background story of this upcoming feature. It allows you to better understand what you're currently migrating, and that is a great win. So imagine we did the migration, right? We added the fix that Xcode recommended. We added the add concurrent attribute, and we run a code again. So we start on the main thread. Then we perform the async method, which now runs on the background thread again. And then we go back on the current thread. So migration tooling is super important. Manual migration doesn't scale, right? If you have a large code base, it's super easy to make mistakes. And manual changes due to that introduce risk. Imagine all of your code suddenly running on the main thread, right? That could introduce some kind of UX behaviors that you don't want to have in your app. And automation accelerates the progress. If you just have to go over all the warnings, it's much quicker than having to manually find out which methods are suddenly running on the main thread. So existing code might suddenly behave differently. And it's good to know that in the build settings, you can find out whether there's a migrate option, and if so, you can use it. It works a little different for Swift packages where the code will actually be changed. So the add concurrent attribute will be added automatically. But in that case, you can just go over the git changes and find out where the code has been changed. So back to our original story, approachable concurrency. We covered 2 of them now, the non-isolated non-sending and the migration tooling, but I also want to dive into another one, controlling the default actor isolation inference. You can find this in the build settings as well. And the default is non-isolated, but you can change it to main actor, which is actually main actor all the things. Imagine we enabled it and we set it to main actor. and we run a code again. Behind the scenes, your class suddenly runs on the main actor because it gets attributed with the add_main_actor attribute. This also means non-isolated non-sending will no longer have an effect, right? Because it's no longer a non-isolated async function. And this is important to realize, because if we run the code again, we start on the main thread, then we perform the async method, which runs on the main thread. And then we get back on the main thread as well. So once again, existing code, even though you didn't change the code, runs on a different thread. That is super important to realize. And you might want to use instruments or anything like that to find out which pieces of code need to be adjusted if you use default actor isolation in an existing project. The fix, once again, is to use add concurrent, and it ensures that that method runs on a different isolation domain. So to wrap up that feature, all your code will run on the main thread by default, and it risks blocking UI, which could also result in an App Store rejection. For new projects, turn it on. Many projects are more than fine to run on the main thread by default, and in fact, this was how it always worked. The dispatch queue was always set to the main queue for existing projects that didn't use concurrency. So it might be perfectly fine. And at the point that you need more performance or you want to run stuff on the background, you opt out of the main actor isolation. That is the default. For existing projects, honestly, it's case by case. If you know a package is full of UI code, it might make sense and it prevents you from adding add_main_actor everywhere. However, a project that has all kinds of code inside the project itself, yeah, you might be in better control if you do it all manually. Finally, I want to discuss global actor isolated conformances. And for this example, I introduce you to a person view model, which comes with a constant ID and a mutable name. Note that it's attributed with main actor. Imagine we add the equatable protocol conformance. In this case, we just compare the ID of two instances. Xcode will warn us, and it gives us a few fixes. The thing is, Xcode can't be sure that this conformance works because we attribute it to the main actor, and you can't suddenly switch isolation domains if we didn't change this code. So there are a few fixes that Xcode gives, and I want to cover each of those. So the first one is to mark the declarations with non-isolated. We basically opt out with this method from the main actor isolation domain. That also means that we can use this is method, this equatable method, from any isolation domain, so there are no concurrency issues anymore. Now, you can only do this if the pieces of code you use are sendable, if they are usable across isolation domains. And I'm telling you this because we could change this and use the name property as well. However, the name is mutable, and that means it can be changed at the moment it's being read. And that's a classic data race potential crash, right? So this is not allowed, and we need to fix this differently. And that's where this proposal is about. We can say like, hey, I want to make person view model equatable, but only on the isolation domain main actor. In other words, we can now only compare person view model without compiler errors if we are on the main actor isolation domain. We can remove the non-isolated keyword again because that's no longer needed. And I can basically wrap it up as person view model only being considered equatable on the main actor, ensuring thread safety and predictable behavior. And if you call it outside of the main actor, you violate this assumption and you trigger a compile time error. Once again, compile time, thread safety. So how do you approach migrating to approachable concurrency? Don't do this. You change the value of the build setting, but many of the upcoming features change accordingly. You don't migrate manually here, you opt in directly, and that can cause a lot of problems. Instead, enable the features one by one and use the migration tooling if possible, just like I showed with the non-isolated non-sending example. And feel free to open a pull request for each individual upcoming feature. It creates this isolated domain, isolated context, which is great for yourself, but also for your colleagues that will have to review the PR. They might be new to this upcoming feature. They need to read up on it. And if they have to learn multiple upcoming features at the same time, reviewing the PR becomes so much more complicated. And finally, only enable the approachable concurrency build setting in the very end, when you manually turned on each related upcoming feature, so you ensure that your code will work the way you want it to work. Now, I also want to give you a few migration strategies that I used myself that will help you, guide you through the whole migration. And I like to think about it this way, right? If you do something every day, even if it's just 1%, it will eventually compound and result in a lot of changes, and you'll get closer to the end destination being approachable concurrency. And migration habits will help you in this. If you think about migrating to strict concurrency in Swift 6.2 as a whole, it's a very big step and it's intimidating. But if you think about, I just want to migrate this single Swift file to strict concurrency, it becomes much more approachable. So, try to turn it into smaller steps. Consider using Sendable by default. If you create like a new model or response model, add the Sendable protocol. By the time you need to use it across isolation domains, it will work out of the box. Sometimes it's explicitly added already by the language itself, but sometimes you need to add it yourself, and that can greatly help you in the future. You'll touch a lot of old code during the migration, and it's so easy to think, okay, I want to refactor this as well. I want to rewrite it a little bit, but don't do that. Your focus should be concurrency. Now, if you really need to refactor to make concurrency even work, like refactoring a closure-based method, that is fine, but don't rewrite the whole instance. Instead, open up an issue for it and revisit that later when you're no longer in the concurrency context. And focus on minimal changes as possible. Now, this is really minimal, just adding Sendable to an enum, but you'll get my point. Smaller PRs are easier to review, they get merged quicker, and you don't want to have like 20 PRs open, having to go back and forth between all those PRs, right? This is super important with large migrations. And reduce future tech debt. If you start a new package, start a new project, make sure to enable Swift 6.2, consider default main actor isolation, and also consider approachable concurrency. And don't just main actor all the things, right? It might be okay to do it, but be conscious about that decision. So how would you migrate existing code? I like to give you a few steps. First of all, find a safe environment. And with that, I mean maybe a single file or a single package. Ideally one without dependencies, because think about it. If you update that package and some package relies on that, you'll suddenly have to update that package as well because it has to work with concurrency. And that makes it super hard to open a PR that will keep your project building successfully. So start in an isolated domain, get yourself familiar with migrating to strict concurrency. Increase strict concurrency checking. If you're able to stay on Swift 5, this is a great way to move forward to Swift 6, where this will be set to complete by default. This could be a great way to slowly move forward to strict concurrency. And for those that don't know, if you set this to complete, you'll get a lot more warnings and errors than if you keep this on minimal. And this is gracefully migrating to Swift 6, so to say. Then enable upcoming features. And it's a little bit of a chicken egg, right? Some upcoming features require you to use Swift 6.2. So it depends on the upcoming feature that you work on, whether you can already do that. For example, the Swift 6.2 features, you can't start with that if you didn't prepare your code for complete strict concurrency checking yet. And finally, after applying all the changes you need, you can turn up the version to Swift 6.2. And this could be a repetition, right? Like you find isolated code you increase the strict concurrency checking, then you enable upcoming features, and finally you turn on Swift 6.2. Open in PR, find a new piece of isolated code, and continue. And this is great, right? Because you can do some work in a small amount of time if you have an hour left on the day. And speaking of that, it's more than fine to reset the settings in between. Turn on an upcoming feature, fix a few warnings, turn off that upcoming feature again, and open a PR. It will slowly but surely bring you closer to migrating completely to that upcoming feature. And I also want to share you a few experiences, right? RocketSim, my Mac developer tool for iOS engineers, has 20 plus packages, and I migrated it successfully to Swift 6.2. And this is one of the crashes that I was running into. Now, my project was released. I had no compile errors, no warnings anymore. So from the surface, it all looked good. But suddenly new crashes showed up, and I had no idea what was going on. Eventually, I was able to reproduce it and know that it's saying block was expected to execute on a certain queue. And this was caused by combine, where the sync method at the moment of speaking doesn't work great together with main actor attributed methods. Nothing is stopping you from calling it from a background thread. And that caused this crash because the notification center expected the code to run on the same queue as where the notification was posted on. Fully understand if this is hard to follow, so I have a dedicated article about this. There's a link in the description if you want to read more about this. Highly recommend reading this if you're using Combine and you want to also support strict concurrency. Another lesson is that mistakes are easy to make. I'll give you a few seconds. Do you see what's wrong in this code? It's actually this line. I was kind of reading this as a regular for loop, and it turned out that it's not, right? It's a for await. It's kind of like an asynchronous for loop that continuously waits for future notifications to arrive. But, I only want to run the actual update applications method in the bottom if certain checks are true. And if not, I basically returned, which, normally with a regular for loop might work. But for this case, it breaks the whole observation and, the code was basically not working as I thought it would work. The fix is easy. I should have used continue in this case, but it's a part of an example of a mistake that's commonly made. And that's why I created a free 5-day Swift concurrency playbook, which gives you 5 emails, every day 1 email with 1 mistake. And these are common mistakes everybody makes. For example, you might have been using the onAppear modifier in swiftui and created a task inside that onAppear. Well, that's also a mistake, and there is a much better solution. Scan this QR code or check the link in the description and you can sign up for free. You get all those 5 days just for free in your email. And last but not least, I also created an essential Swift concurrency course to help you migrate to Swift 6. I will teach you all the insights about Swift concurrency, 65 plus lessons, and I'm actually writing new lessons as we speak that will help you master Swift concurrency. Many teams have already done this, and they finally migrated to Swift 6.2 successfully. There's a link in the description, and of course, I would love for you to like this video if you enjoyed this talk, or subscribe to my channel for any future concurrency videos that I will post. And with that, thank you.